sum. So we are giving binary nums. It's going to be 0 and 1, and we also have an integer goal, and we're going to return the number of non-empty subarrays with a sum equal to this goal. So if the goal is 2, we want to find the subarrays, because subarrays is a contiguous part of the array. So for example, this is one part, yeah, and this one going to be the second part. Even we include a 0, so this is okay. This is also subarray. And now we have this one and the last one. So there are 4 subarrays, so we're gonna return a 4. So what kind of a solution we can use basically to solve such kind of problem? Maybe we're gonna think about the sliding window solution. So we're gonna prepare a left and a right pointer. We're gonna prepare a left writer, and we're gonna enumerate to the right, and we're gonna count how many of them. So if it is equal to 2, it means we find 1. So for example, this is the left and this is the right, and from here we find 1. So if we find 1, what are we gonna do? Maybe we want to shift the left pointer from here. So while it is not equal to 2, so we're gonna steal from here to calculate. Yeah. But this is not right, as you can see. If you directly use a sliding window, you cannot solve the problem, because from here, definitely you find 1. And then if you shift to the left pointer, from here you find another 1, and from here you find another 1. It is 3, it is not 4. Yeah, but our answer is 4. So it's difficult, I think, to use sliding window to solve the problem. And for this problem, actually, we can use prefix sum to solve it. We can use actual memory as array, or we can use actual memory as a hash table to solve it. But the best solution for such problem is to use hash table. But first of all, let's try to use an array to solve the problem. So we're gonna prepare a prefix. Yeah. So I call it prefix array. Yeah. So let me just call it a prefix array. So we're gonna prepare a prefix array. So from the first place, I'm going to prepare one padding as 1. Because if I plus some numbers, for example, 1 plus 0 plus 1 equal to 2, I want to get a result, and this result should minus the prefix of position 0. Yeah. If it is a value of 1, it means I found one solution. So this is why I prepared a padding. So for other places, I don't know yet, so it's going to be 0 times n. Yeah, so this is for the prefix array. Now I want to prepare a total. Let me prepare this variable n. It's going to be the length of the array, and I want to prepare a total and the result. So n going to be the length of the nums, and total going to be starting 0. Result also be 0. Total going to be the sum up of all the values. So I'm going to check all the values inside the nums. So the total going to plus equal to this way. The current value. So if I get a current value, I want to check the result, how many of them. So the result going to be equal to the result would plus equal to the prefix with. So what is my goal? My goal is 2, and what is my total value? So I just wanted to check if this total value minus the goal is inside a prefix array or not. Definitely it is inside, because I prepared a larger range. Definitely I times n. So this is because why I times n? Because there can be zeros, or it can only be 1. So how many different numbers I can have? So at most it's going to be n. It's going to be length of the array. But it can be zeros. So actually, yeah, I also prepared a padding, and I also prepared all the possible positions. I times n. It means I can have all the positions. Even inside the array, all the numbers is 1. It is still okay. Yeah. Now we want to check. So if the total minus a goal is inside my prefix array, definitely it is inside. It may be 1, or it may be other numbers, or it may be 0. Yeah. So I want to check that. And after that, I want to update my prefix array. So my prefix array going to be this total plus equal to 1. Yeah, because from the beginning, so for example, from here, I check the total value of 1, I find 1, and from here 1 plus 0, so the position is also 1, so 1 is my index, so index 1 I find 2 numbers. Yeah. And finally I just need to return the result. Let me just run it first to check. As you can see, it works, but let me just print out the what is this prefix and why we can use this kind of a prefix array. This is not a really prefix array, and this total value is also used some kind of a prefix method. We just need to sum up all the values, but this prefix array is used as a hash table. As you can see, this is just to count the positions. So for number 0, how many? It is 1. It is just a padding. And for number 1, sum up of the values to be 1, how many? There are 2. And for sum up of the 2, how many of them? It's going to be 2. Yeah. So this means this is why we're going to use the total value minus the goal. Yeah. If it is equal, so we're going to record the result. So I think this is okay to explain why. Yeah, definitely from here. So this is 3, and 3 minus the goal. The goal is 2. Yeah, so it is 1. So we're gonna check the prefix of 1. So there are 2 values, right? And also we can check this one. Yeah. So this one, the total value is 2. It is the index is 2, and we have the 0 index. So it's gonna be this one. The total minus the goal. It's gonna be at index 0. So it's gonna plus a 1. Yeah, and yeah. Let me just print out the result. Maybe it is much more clear. Yeah, now let's just see the result. So from the beginning it's going to be 0, and then we're going to plus a 1, because from here we find 1, we're going to count 1, and then we're going to have a result of 2. We find another 1, because at here, at this position, we find another 1, because this is a 2 minus goal, it is a 0, and 0 position, it means another 1. This is for sum up, the total value is 3. So 3 minus goal, it is 1. So it is a 2 here. So it's going to plus a 2. So it's going to be 4. So this is the idea. Definitely, if we are using Python, even the array prefix use the actual memory, but it is much faster. Let's just check that. As you can see, it is nearly 100%. So the array is much faster. This is just because of the Python. For array, it is much faster. If we use a hash table, we can save actual memory. Yeah, let's just try to use a hash table. So we're going to turn this array. So the normal way to solve this problem and the best way is to use a hash table, because it saves the memory. And basically, we don't need to use some other memories. Maybe, this position is just 0. It means it is no meaning. We don't need that. So this is why we're going to turn this problem to a hash table. So for the hash table, we're going to use this prefix equal to default dict. We're going to turn this to a hash table, and we're going to use this prefix 0. We're going to set it to 1. So this is the default. We're going to prepare the 0 to 1. This is just easy for calculation. And now we just check, and here going to be the same. And now let me just run it. As you can see, it also works, and I think this is the best way to solve the problem. Yeah, as you can see, the speed is, I think it's nearly the same, but this is better, and the time complexity is just ON. And this kind of idea is just we prepared some numbers. So the idea is that we have an array. We have a hash table. Inside of the hash table, we prepared some numbers. So for example, we just count the number of 2, the sum up the total value of 2. How many of them? Maybe 4. And for the next one, if we find a number, the total value of 4, we're going to count how many subarrays. because up to here, so for this number 2, we have a code of 4, but our goal is 2. So 4 minus the total value of 4 minus my goal, it is 2. Yeah. So how many of them? I just need to check. Also, there are 4 of them. So it means I'm gonna plus a value of 4 as my final result. I'm not sure if this is easy to understand or not, but definitely this is a very popular problem to use the prefix sum and hash table to solve the problem. Yeah, so this 2 means the sum up of all the values is 2. It may be like that. This is a 1, this is a 1. So from here we have a code of 2 equal to 1, and then it is 0, 0. So we're gonna still code it. Yeah. So until we accumulated the values to 4. Yeah. Until we accumulated the values to 4, and next, if we find a value, maybe there's another one. So this is also 0. So up to here, as you can see, the total value is 4. Yeah, because 1 plus 1 plus another 1, this one and this one, the total value is 4. And we want to check the subarrays equal to 2, because our goal is 2, and we want to check how many of them. Yeah. And because up to here we have the total value of 2, and up to here the total value of 2 gonna plus 1, it's gonna be 2 and 3 and 4. So we find four values basically. Now we have this value, it's gonna be 3. Yeah. So 3 minus the goal. 3 minus the goal is 2, it is 1. So at position 1, at value 1, we want to find how many of them. So here is 1, so we find 1. And at this position, it becomes 4. So we're gonna count the 2. So there will be 4. Yeah. But while we are coding the sum up of all the values to be 2. So as you can see, this is 1, and this is another 1, and this is another 1. So 1, 2, 3, and this is another 1. It is 4. Yeah, we just started in a dictionary. So for the next value, if we find a value, maybe that is 4. So 4 minus the goal 2, it is 4. So we can directly, look up it inside the hash table, because they have a code of 2. They have the sum up of all the values to 2. We have 4 different kind of combinations, because we accumulated like that. Yeah. Now we find another value. It is 4. So it means 4 minus this 2 equals to our goal. So 4 minus goal equals to this value. So we can directly find it, look up it inside of the hash table. Yeah, so this idea is the prefix sum. So in this way we can check the values efficiently just in own time. I think that's for it. Thank you for watching. See you next time.